Welcome to lesson 3.5 on the inverses of linear functions, which is actually a review for you guys because we did it back in lesson 2. So we're going to start off right with an example, two examples actually. Examples 1 and 2 ask you to find the inverse of the following equations. So as a quick review, inverse means switch x and y, and then you have to actually solve for y. So the numbers stay where they are. Some of you, when we did this back in lesson or unit 2, you would switch, when you switched x with y, you would take the 5 with the x. No, you just literally switch the x with just the y, not the numbers. So the 5 stays where it is and the negative 20 stays where it is. So this will become x equals 5y minus 20. So that is the inverse, but we then need to solve for y because our equations always look like y equals, not x equals. So we're going to add 20 to the other side to get x plus 20, and then we would divide the 5 over. And just for right now, so there's two ways you could leave your answer. You could leave it like this. So your answer is x plus 20 all divided by 5. Or you could divide each the x and the 20 separately by 5. Sometimes that is helpful because the 20 can be divided by 5. The x cannot, so it just stays x over 5, but then 20 divided by 5 is 4. Now I'm going to leave both answers here. This one might be better to leave your answer as, just because you're less likely to make a silly mistake. Some people might end up accidentally dividing wrong, and then they'll lose points when they actually had the answer right. But I'm going to leave this one here because we're going to need to look at that for this question down here. So example 2 is a little trickier because there's a fraction involved. Please listen carefully and take note. When you see a fraction with a variable written where the variable is like in the middle, please rewrite it so that the x, or whatever variable is on top with the top number. It is never on the bottom unless it is clearly written on the bottom. If it's in the middle, it always goes with the top number. I always rewrite it like this. So instead of rewriting it and then having to rewrite it again when I switch my x and y, I'm just going to switch my x and y first. And when I write the y over here, I'm going to clearly put it on top with the 2. Okay, so now we're going to get y alone. So we got to subtract the 8 first. You always get rid of anything that's added or subtracted first. So that's x minus 8 equals 2y over 3. And now it is very clear what I'm going to do next because of the way I wrote it. I need to get rid of anything on the bottom first by multiplying it over to the other side. So if I multiply that side by 3, they cancel out. Now be careful because you got to multiply the entire other side by 3. So you will get 3x minus 24 equals 2y. And lastly, you're going to divide everything by 2. And again, I'm going to leave it. This is one way to leave your answer, 3x minus 24 all over 2 equals y. Or you could divide them separately. So you would get 3 halves x minus 12 equals y. But again, I want to look at this one to answer this question down here. It says, what is the relationship between a function and its inverse? Well, if you notice, here's the original, and here is the inverse. The inverse involves the inverse operations of the original. So if you look in the original, you were multiplying by 5 and subtracting 20. Well, look at the inverse. We're dividing by 5 and adding 20. So inverse means opposite. So the inverse, write this down, the inverse includes the inverse operations, and inverse, again, think of it as opposite. So the opposite of adding is subtracting. The opposite of multiplying is dividing. The opposite of squaring is square rooting. Operations, the inverse operations of the original, but in reverse order. So that's kind of very important to see that because that's a quick way to check if you did this right. you know, in the original, I was dividing, or I was multiplying by 5 and subtracting 20. So I should be doing the opposite in my inverse. The opposite of multiplying is dividing. The opposite of add or subtracting is adding. Same thing over here. We were adding 8. Oh, this one's kind of a poor example just because we ended up using the inverse of the fraction. So it's going to look weird. But we were adding, so it's not quite the same number, but the operation that in the inverse is subtracting. Over here we were multiplying and dividing, so we're actually going to have multiplying and dividing again because those are the inverses of multiplying and dividing. They're inverses of each other. Okay, onto a graph. So this time they actually graphed the original for you. So they graphed the line 2x minus 4, and then they graphed this line. This is the line y equals x. If you're not sure how they graph that, recall that if there's no number in front of x, there's a 1. And if there's no y-intercept, it's a 0. So you'll notice it's a line that goes through 0, it goes up 1 over 1, up 1 over 1. So that's the line y equals x. And we're going to need that to answer part C. So back up in part A, it says, how can you quickly tell that y equals 2x minus 4 is 1 to 1? Well, remember, to tell if it's 1 to 1, we talk about the horizontal line test. So you can say it is 1 to 1 because it passes the HLT, the horizontal line test. Part B says graph the inverse of 2x minus 4. Remember, to quickly graph, you could sit here and you could find the equation of the inverse, you know, switch the x with the y and then graph that line. That's actually not a bad thing to do. But if you don't want to do that, you could just switch all of the points, switch their x's and their y's. So for example, this is the point 2, 0. So he would switch to be 0, 2. Okay, and then you're going to do that for a couple more. You should do at least a couple more. So this is 3, 2, so it's going to be 2, 3. And then this guy, you'll notice he's a special point. He's actually on the line y equals x. And if you switch the point, this would be 4, 4. If you switch 4, 4, it stays 4, 4. And that's enough for now. So I'm going to connect those 3 points and extend my line with an arrow. And now part C says, what do you notice about the original graph, 2x minus 4, and his inverse? Back from geometry, you should notice that each point is a reflection over that line, y equals x, to get the point on the inverse. So you should write down, it is a reflection over the line, y equals x. If you were to fold your paper on this line, y equals x, your original line would match up with your inverse line. So that is how to quickly kind of graphically tell if you graphed the inverse correctly. Does it look like the inverse is a reflection of the original over this diagonal line y equals x? Okay, up next is lesson 3.7. We're actually skipping 3.6 for right now. So 3.7 is next. And 3.7 is on systems of linear equations. So you have done systems before, back in 9th grade. So there were a couple of methods you did learn. There is a third one. It's not listed here. It's graphing. You could turn these into linear equations and graph them and find where they cross. So when you are solving a system, write this down. You are finding basically where they intersect. You're finding the points that they share, finding where they intersect. Now, if it's a 3 by 3, which we're getting to in a minute, you guys have never graphed in a 3-dimensional world. We've only graphed in a 2-dimensional with x and y. There is a 3-dimensional grid that you could graph on, but you are not going to get there unless you take like Calc 3. So that is far in the future. So we are finding where they intersect, or what you're basically doing is you're finding the single point that they all share in common. So you're finding what point they all, share in common. You're finding what number could you plug in for x, y, or x, y, and z that makes all of these equations true. So there is hopefully a single number you can plug in for x for all of them, a single number you can plug in for y for all of them, and a single number you can plug in for z. And when you do that, you will get these numbers on the other side. So as a quick review, I'm actually going to show you elimination and substitution with the first one. First, my favorite is elimination. To do elimination, you're going to end up adding the two equations together, but when you do that, you want one of the variables to cancel out. In order for that to happen, one of the variables has to have the same number out in front, except one of them has to be positive and one of them has to be negative. So right now, that is not true. The x's have a 3 and a 2. If you add those together, you'll get 5. The y's have a 2 and a 1. That added together will give you 3. But if I multiply the bottom, and you got to multiply the entire bottom, by -2. So I am doing that because look at what's going to happen to the y now. And don't forget to multiply this side by -2 as well. You got to multiply everything. What happens now is that the y's both have 2's in front of them, and one is positive and one is negative. So now when I add those together, the x's don't completely cancel out. They do turn into -1x. But the y's go away because 2y and -2y is 0y's. So I'm not even going to write that down because it's gone. And then -9 and +14 is 5. And then my last step is to get y or x alone. And there's a negative, remember there's an imaginary 1, there's a -1 there. So I'm going to divide the -1 over to the other side. And you get x equals -5, sorry. Now you're not done because you have to solve for all variables. We only solved for x. We have to find y. So all you have to do is pick one of your equations and plug in what you got for x and solve for y. So that's -10 plus y equals -7. When I add 10 to the other side, you get y equals 3. So your solution is the point -5, 3. Now to do substitution, you have to get, in one of the equations, you have to get a variable all alone. Then you take whatever that variable equals and substitute it into the other equation for that variable. So for this particular one, I'm going to get y alone in the second equation because it's the easiest one to get alone because there's no number in front of y. So I don't have to end up dividing by anything. All I have to do is subtract the 2x to the other side. So you get y equals -2x minus 7. Now you're going to take what y equals and plug it in to the top equation, the other equation for y. Because I know that y equals this guy, so I'm going to put this guy in for y. So I replaced y with what he equals. Now the whole point of doing that is now look at what we have. We have an equation with only x in it, so we can solve for x. So if I distribute the 2 in, that's actually a -4x and a -14. And you will notice you're going to start seeing some numbers that we saw over here in elimination when we added those together. So you get -x. I'm going to move the 14 over to the other side, so that is 5. And then again, divide by -1, so you get -5 again. And again, you have to then plug that in and solve for y. So I'm going to have -2 times -5 minus 7, which turns out to be 3 again. So good thing I got the same answer because all I did was the same question but 2 different methods. So pick your favorite and stick with it. Now for the 3 by 3, it's a little tricky. 3 by 3, we can't really use elimination or substitution right away. We're going to have to use like elimination a couple times. I'm going to number these instead so I can talk about them. Let's number the first one as example 1 or equation 1, equation 2, and then this will be equation 3. Okay, so first thing you want to do is you want to add together, you want to use elimination and add together 2 equations to get rid of 1 variable. Then you're going to have to add together a different 2 equations to get rid of that same variable so that you'll end up with 2 equations with only 2 variables instead of 3, and then you can use elimination or substitution like we did up top. So let me work through this example with you. I'm going to add, step 1, I'm going to add equation 1 and equation 2 together to get rid of the z's. So I'm going to rewrite those. So 2x plus y plus z equals 15, and 6x minus 3y minus z equals 35. Be careful, my z's sometimes end up looking like 2's. Now, if I add them together right away, the z's are going to cancel out. So I don't have to multiply anything by any number because these are going to go away right away. But the x's and y's don't, which is good. I get 8x minus 2y equals 50. So now I have an equation with only x and y in it. Now I'm going to add together 1 plus 3. So I'm going to rewrite 1 again. 2x plus y plus z equals 15. And 3 says negative 4x plus 4y minus z equals negative 14. Again, I don't have to multiply any equation by anything because the z's are going to go away right away when I add them together. So this is negative 2x plus 5y equals 1. Now I'm going to use elimination or substitution. I like elimination with these two and get rid of either x or y. So then I can solve for x or y, and then I'm going to have to plug everything back in to find the other missing variables. So I'm going to rewrite these so they're on top of each other. And then I'm going to figure out which variable I want to get rid of. So if I multiply the bottom one, let's multiply the bottom one by 4. And if I do that, the bottom now turns into negative 8x plus 20y equals 4. So now if I add the top with this one, the x's are going to cancel out. But now the y's, so that becomes 18y equals 54. Divide, now I only have y, so I can solve for y. Divide by 18 to get y equals 3. Okay, all of that work to find just one variable. Now I have to plug that in to one of my equations up here where there's only 2 variables. So I will pick this one. This one has smaller numbers. So I'm going to replace y with 3. So that's 15. So subtract the 15 over. You get negative 2x equals negative 14. Divide by negative 2. X is 7. Now I lastly have to find z. So I'm going to plug in 7 and 3 for x and y up into one of these. I'm going to pick the top one. So instead of x, I'm going to write 7. Instead of y, I'm going to write 3. And then I got to keep z because that's what I'm solving for. That is 14 plus 3 is 17. And then subtract the 17 over, you get z equals negative 2. So there is your final answer. You need all 3 of these variables solved for. So the hardest, or the part that's kind of the trickiest, is remembering to go back and solve for the other missing variables once you get to the end. It's a lot of work. It's not necessarily difficult work, but it is a lot of work to show. So make sure you show me all of your work. And that's it for lesson 3.7.